up so we can get going on this next section. Okay, so what we were going through was how to take a function and a closed interval and be able to determine the absolute extreme values with calculus and then be able to verify that on a calculator. Okay, so a couple of things you got to check on this. First of all, the extreme value theorem is what we were talking about. And the extreme value theorem, again, what it means is if you had like a closed interval, just meaning the endpoints of the interval are closed, and it turns out no matter how you connect the dots, you're always going to end up with an absolute max and an absolute min, which looks like it's probably that point right there. Remember, absolute max just means the largest value of y that you ever hit. The absolute min is the absolute smallest value. That's all that is. Okay? So when you look at this, see, I've given you a closed interval, so that's a yes. And this is continuous. The reason this is continuous is because that graph's a polynomial. Okay, so what you learn in college algebra, this is an even polynomial. The leading coefficient's positive. This graph's going to do this. And it's going to maybe curve a couple of times, but it's nice and connected everywhere. So that means that, yeah, we do satisfy the extreme value theorem. That's why we're allowed to do the technique that we're going to do. Okay. All right. What do you need to do to find critical numbers? You find the derivative, and what do you do with the derivative? Set it to 0. Good. Okay. So this problem's not too bad. Your first derivative, I'm confident everybody can do that one with no problem. That's 12x to the third minus 12x squared. And then you just want to set that equal to 0. Now, critical numbers can occur where the derivative is undefined, but that derivative is defined everywhere. X can be anything, so all we got to worry about is what value or values make that derivative 0. All right, how do I solve that equation? Factor of 12x squared, good. Okay, so when we do that, you'll be left with an x minus 1 like that. Can you do the critical numbers in your head now? What are they? 0 and 1. Yeah, okay. And don't overlook that a lot of times you can just do that in your head, so you don't have to show these steps right here. Technically, you could divide by 12. That's really unnecessary. You take square root of both sides. You get x equals 0. And over here, again, I'm just pointing out, sometimes you'll have to show some steps, sometimes you won't. So your critical numbers are x equals 0 and x equals 1. Okay, so that's what you're going to be doing to start the problem. Okay, now what we learned in the last class was basically if you're going to determine an absolute extreme, you have to do two things. First thing you have to do is you have to work with the endpoints of the closed interval, and that is just -1 and 2. Those are your endpoints. So what you do is you evaluate the function, not the derivative. We're done with the derivative. So you just want to do f of -1, plug that in and calculate. So that'll be 3 times -1 to the fourth minus 4 times -1 to the third. And that looks like that would be 3 times 1 minus 4 times -1. So that is 3 plus 4, that is 7, is what that is. Use your calculator if you want to use your calculator if you need to. Okay, and then what we'll do is f of 2, which is the other endpoint. Again, plug that into the function. So you'll have 3 times 2 to the fourth minus 4 times 2 to the third. That is 3 times 16 minus 4 times 8. So that is 16, I believe. That's 48 minus 32, so that's 16. Again, use your calculator if you want to. Okay, that's fine. Okay, so we do that. Now, the next thing that you got to do, so we kind of looked at the endpoints because a maximum or min can occur, a global max or min can occur at an endpoint. So what we do now is we do the critical numbers, and we just kind of do the same thing. So we'll do the critical numbers, which are 0 and 1. So we're going to do f of 0, and we're going to do f of 1. Again, plug into the function. So you'll have 3 times 0 to the fourth minus 4 times 0 to the third. Do that in your head, that one's equal to 0. So that's what the function value is, okay? Do f of 1, that would be 3 times 1 to the fourth minus 4 times 1 to the third. That would be 3 minus 4, so that's equal to negative 1. Do things in your head if you're confident. Use your calculator if you need to. Okay, now it's real easy to finish up the problem. Which of those 4 numbers is the absolute maximum? 16. Okay, that's your absolute max right there. Which of these 4 numbers is your absolute minimum? Negative 1. Okay, so that is the absolute minimum that you get there. So what you do is, if you have a closed interval, the absolute or global max and min occur at either the endpoints or the critical numbers. They're not going to occur anywhere else. That's why you can do this technique that you use on that then. Now, when we write our answer, typically what we do is the absolute max. The way you write the answer typically is you give me the y value, and then you just say like when or x equals 2. So if x equals 2, you get the y value of 16, which is the highest point. And then your absolute minimum, again, you give the y value, which is negative 1, and you say at x equals negative 1 like that. Okay, and that's the way you want to do this when you're doing your homework. You want to run through this procedure so you're confident with it. Sometimes when you do homework and stuff on web work, I don't know really what you're doing. You could certainly get the answer to this problem right by doing this. I'm just going to put this in the calculator real quick to verify. So if you want to graph this, you can do this. And this is really, as you're learning this, so this ought to be something you use to verify. So that's the function. And then when you do your window, only consider negative 1 to 2. Okay, consider that closed interval only. And then as far as y, well, 16 is the max. I'm just going to go negative 20 to 20. It's up to you what you use, but you just want to make sure that the max fits in that interval and so does the min. So if I put something in like that and graph that, you can pretty well see that here's your max right here. So you could trace at 2, okay, and that verifies that 0.216 is your absolute max. You could trace at negative, let's see, where did the min occur? The min occurred at 1. So you could also trace at 1. And then you can visually tell, hey, that's the absolute min. Okay, now if you do your homework just on your calculator, you could get it done, but you wouldn't learn anything. Okay, so it's kind of up to you how you do that. If I give you a written assignment with this that you'll be doing over the weekend, then this is what I want to see. If I ask for absolute max and min, that's the technique that I'm looking for. Okay, so that's the idea. All right, any questions about that? Okay, so that's fairly straightforward. That's not too hard to do, unless the derivative's complicated. If the derivative's complicated, the problem can get a little complicated. Okay, so last thing I really want to do is work with a couple of applications. This one is more physics. Then I'm going to have you do one yourself that's more economics and business. So what this problem is saying is anytime you throw a projectile, it always follows a parabola. Even if you go to the water fountain, next time you turn on the water fountain, you'll see a quadratic function. Okay, right? Basketballs, no matter what you throw, it follows a quadratic function. So instead of you don't have to know what all of these numbers mean in this problem. You learn that more like if you're in a physics class. That's basically your function that is modeling the projectile, that stone, when it's being thrown. Okay? So what we're going to do on this is, again, you're given a closed interval. So we have this closed interval, and we have a continuous function because it's a parabola. That means that we can do the extreme value theorem. So I'm just going to make a note to myself that the extreme value theorem, that holds. So that means essentially what we do is we find critical numbers. We evaluate the endpoints in the critical number, and whichever one's the biggest is the maximum height, right? That's what it is. Okay, So let's go ahead and start by finding our derivative. And that derivative is going to be negative 32t plus 64. And again, what do I do with that derivative? Set it equal to 0. If you want to find a critical number, you want to set that equal to 0. So we have 0 is negative 32t plus 64. I would just move the 32 to the other side. Okay, so we get 32t equals 64. Then I can divide by 32. So I get t equals 2 seconds is that's where the critical number occurs. Okay, that might be the max or maybe it isn't. Maybe it's the min. We don't know. So again, what we do is exactly what we did on the last problem, is you go ahead and evaluate your endpoints, which are 0 and 6. So you're going to do S of 0. And so just plug it in, use your calculator or do it in your head. Okay, so that one seems to be pretty easy to do in your head. That's going to give you S of 0 equals 192 feet. That's how tall that is. The units were given in the problem as feet. Okay, so we do that. Then we do S of 6. Okay, so plug 6 in. We have negative 16 times 6 to the second plus 64 times 6 plus 192. I have a strong feeling that that's 0. I don't know, but I'm going to plug it in just to make sure. Because when I make up these problems, I try to make them up this way. So let's see, negative 16, 6 to the second is 36, and then plus 64 times 6, and then plus 192. Let's see if I'm right. Yeah, that's 0, okay? All right, so that's 0 feet. So what does that mean if the height's 0 feet? What's happened to the stone after 6 seconds? It's smashed into the ground, right, exactly. Okay, so that's logical. Okay, so now what we need to do is do the critical number, and that critical number was 2. So again, we just plug in the 2 seconds. We're going to work out negative 16 times 2 to the second plus 64 times 2 plus 192. Okay, and then again, I can do some of this on the calculator. So let's see, this one I've got negative 16 times 4. For 2 to the second is 4, and then 64 times 2 is 128, and then plus 192. You know, if you can do something in your head, you can. So anyway, that gives you 256 feet. Okay, so what does that mean about that then? Is that the absolute max? Yeah, okay, so that's just the high point where that happened. So that means this right here is your absolute max, okay? And what they're saying is the question says, when does the stone reach its maximum height? So that will happen after 2 seconds. And then that height is just going to be 256 feet like that, okay? So that's the same basic idea. If the derivative is simple, which it is on a problem like this, then the problem's pretty simple to do. Agreed? Yeah, okay, because the algebra, once you set the derivative to 0, then that's fairly straightforward to do. Okay, well, let's do this on the graphing calculator and just do a sketch to kind of see if this looks right to us. The whole purpose of that mostly is having the ability to use technology to check and verify what you do. Okay, so you'll have to use x instead of t, so put in negative 16 x to the second plus 64x, and then plus 192. And then we got to set up the window, okay? So sometimes this is the hardest part of the problem. What's my x window? 0 to 6, because that's what I told you, right? So we only care about 0 to 6 seconds. A good way to scale that would be by 1. Okay, and now as far as y, you're going to start with a height of 0. You don't worry about negative heights. How high do I need to make that go? At least 256, right? Okay, so I'm just going to go ahead and do 300. Whoops, not like that. So the minimum 0, then I would do 300, And then you could maybe scale 100 would be a good choice on that. And then that gives you kind of a nice graph, okay? And what'll happen on this is, where did we find the max to be? That was how many seconds? 2. So if you traced at 2, then you can pretty well see that. Visually, you can tell that's the highest point, and that Y value is how tall it is, okay? So that's all it is, really, okay? All right, now as far as sketching a graph, all you really need to do is just label your, this is really a t-axis. So we'll go 1, 2, 3, 4, 5, 6. It's okay if you just label that last one, and then you know that the rest of them are worth 1. And then we did, I think, 100 feet, and then 200 feet, and so forth. And then really all I'm going to do on this is just get some points on here, okay? So if you start at 0, if you trace at 0, you're going to notice that that's 192. And that in the beginning of the problem, it said that was the initial height. So I'm just going to estimate that, maybe label that point. Okay, then we set at 2. When we trace at 2, we get 256. So I'll just kind of put that up there. And then finally, when we got to 6, we were back to 0. Okay, so then from there, you can just kind of sketch it in like that. That's how that goes. Okay, all right. All right, now, I don't know if this is worth showing or not, but I'll show this to you just because I think it's cool. I don't know what you all think. If you actually go to that, get your cursor blinking on that right there, and if you keep pressing either your down, no, I'm sorry, you keep pressing enter, what it'll do is this thing right here can be changed. Right now it's a line, so you can change it to several different things, I think. This may not even be worth showing. I don't know. I just think it's cool. Maybe I have to go like this. Maybe I have to, crap. Maybe I'll do like this. Well, that's disturbing. I guess it's going to work. What it's supposed to do is it's supposed to change that. Eventually, you'll see a ball. So what'll happen then, instead of graphing a line, it'll just make a ball go like that. I just think that's cool. Oh, well. Sorry, it doesn't work. So anyway, oh, there it goes. There it goes. Okay, right there. See, it's just a ball. Now check this out. Ah, crap, you got to start it over again here. So let me start it all over again. Sorry, I'm kind of wasting my time, but I just think it's cool. Shoot. Okay. It would have worked, and it would have been beautiful seeing that ball. Anybody try that? Okay. All right. Okay. That's just something I happened to think of when I was doing that. Okay. All right. Let's see. So go to the next page. This last page, I want you all to just do this problem yourself. And it's very similar to what we just did, except what you have now is this is a revenue function. And instead of x being in the revenue function, you have a price. Okay, so that's a little bit different twist on that. So what you're really going to be doing on this is you've got this closed interval 0 to 5, and then you want to find your critical numbers like I did in the last problem, and then evaluate the endpoints and the critical number to find which is the bigger. Because what you're doing in this problem is you're determining the absolute maximum of the price. Okay? Then finish it up by doing a graph, and then that'll kind of close off this section. Okay, all right? Were you trying to do what I was doing? After you get the $2.50, then let's see, you plug the endpoints in. You should have got 0 on both of those. Is that what we got? Okay. And then when you take the critical number, which is 2.5, then you do just R of 2.5. So you're going to do negative 60 times 2.5 to the second, and then plus 300 times 2.5 there, and then that should give you the maximum of that y value then, okay? So I just put that in the calculator wrong, I guess. Okay, all right. So what did you get for 2.5, 375? Does that sound right? Okay, all right, very good. Okay, so I kind of did a crappy job on that. So anyway, that would be your absolute max would be at 375. That would be your maximum revenue. And then the price would be $2.50. So this maximum on your graph should have been 2.5 is the price. So that is your price. And then your revenue, your maximum revenue is 375. So that's the way that should have worked out. Okay. Anybody have any problem doing that or anything? Okay. All right. So mainly what we're doing in this part of the section is just working with global or absolute extrema. That's the technique that you use. Okay. And this technique only works if you have a closed interval. So that's all you're going to look at on homework and stuff is just closed intervals. Okay. And then this is the methodology that'll get you there. Okay. Any questions? Guys, everybody got that written down and done okay? Okay. All right. So I'll go ahead. I passed out the 2.6. And 2.6, we are going to learn about concavity. And like I was saying, this is the order I feel like I need to teach this in is more